Hi everybody, this is Unit 5, Video 1. We're going to be writing trig expressions using sine and cosine only. So get ready to take some notes. Okay, the first thing we're going to do is we're going to remind ourselves how to write all of our expressions, our trig functions, using sine and cosine. And then I'm going to give you 4 examples where we go through and simplify after we've converted everything to sine and cosine. So we're going to start with, we know that sine and cosine can be written as themselves, so we're looking at the ones other than that. So for example, tangent of theta, which we know is y over x. Well, if y represents our sine and x represents cosine, then we can write tangent using sine and cosine as sine over cosine. We can write cotangent, and we know that that's x over y. Well, x is cosine, and sine is our y value. So we can write cotangent also using sines and cosines. And then we have our reciprocal functions. We have cosecant, which we can write as 1 over sine, which is the same as 1 over y, but this time we're going to write it using sines and cosines. And secant of theta is equal to 1 over cosine of theta, or 1 over x. So we're going to write it as 1 over cosine. If we were to write tangent as sine over cosine, now you're looking at that saying, what's wrong with that? Except there's no theta. There's no x value, there's no angle variable for that angle. So this would be marked incorrect. It's similar to just saying the square root. The square root of what? The square root is equal to a square root over a square root of what? So this tangent is a function, and you have to have a variable involved. So I would never just write square roots without something in them. So I will never write tangent or sine or cosine or any of the other trig functions without putting the theta or an x value. And you'll see other Greek symbols. You'll see a b for which is beta. You'll see an alpha, which looks kind of like a little fish. So there's a couple other ones you'll see. But these are it's the variable used for the angle. So you must include it, so don't get sloppy in your writing. Okay, let's go ahead. So here I've got secant squared of theta minus tangent squared of theta. And I need to write this with just using sine and cosine. So for the first one, I know that secant is 1 over cosine. So I'm going to write that as 1 over cosine squared of theta because I have secant squared. And I know tangent is sine squared of theta over cosine squared of theta. If tangent is squared, so are both my sine and my cosine. In this particular situation, since I have everything in terms of sine and cosine now, I need to simplify. And I have 2 fractions that I want to subtract, and they have a common denominator, which means I'm able to subtract their numerators, and I leave the denominator alone. So my final answer would be 1 minus sine squared of theta over cosine squared of theta. And that's it. So I can go ahead and leave this like that. It is in terms of sine and cosine, and it has been simplified. Let's take a look at the next one. The next one is cotangent over secant. So cotangent of theta over secant of theta. Well, I need to start by recognizing that my cotangent is cosine of theta over sine of theta, divided by secant, which is 1 over cosine of theta. Well, this is division, and whenever I have division, I'm multiplying by the reciprocal of the denominator. So I'm going to rewrite this as cosine of theta over sine of theta times the reciprocal, which is cosine of theta over 1. So multiplication, I don't need common denominators. I simply multiply across the numerator and across the denominator, leaving me with cosine squared of theta over sine of theta. And that is my answer for this one. So this has been written in sines and cosines, and it has been simplified. All right, the next one. So I have tangent of theta squared times the quantity of 1 plus cotangent squared of theta. So I'm going to go ahead and write tangent squared of theta Actually, there's two ways to do this. We could distribute first or we can distribute second. So I'm actually going to go ahead and distribute second just to show you what it looks like. So this is going to be sine squared of theta over cosine squared of theta. 1 doesn't change, plus this is cosine squared of theta over sine squared of theta. And now I'll distribute. When I multiply this quantity times 1, I just get that same quantity. So it's sine squared of theta over cosine squared of theta. And then when I multiply this, I get sine squared of theta over cosine squared of theta times cosine squared of theta over sine squared of theta. This first piece right here, there's nothing to change about it. It's already in terms of sine and cosine. And this one, the second term, the sine squared of theta over cosine squared of theta times cosine squared of theta over sine squared of theta. Because I'm multiplying those two, I do not need a common denominator. I multiply the top and I multiply the bottom. But what I see is what's in the top is exactly what's in the bottom. So my numerator and denominators will cancel, and this does not turn into 0. If everything cancels, it turns into 1. So this is sine squared of theta over cosine squared of theta. Oops, that should be plus 1. And this is my final answer for simplifying number 3. Number 4, cosecant of theta plus cotangent of theta. Cosecant of theta is 1 over sine of theta. It's the reciprocal of sine. Plus, this is going to be cosine of theta over sine of theta. Once again, I have common denominators, so I'm able to go ahead and combine my numerators together, leaving my denominators alone. 1 plus cosine of theta over sine of theta. And that is as simple as this can get. All right, great job.